Welcome to the DIY Honda Garage channel. DTC P0979 refers to a condition in which the Shift Solenoid Valve C is detected to have a short circuit. The shift solenoid valves in an automatic transmission play a crucial role in controlling the flow of transmission fluid, which is necessary for the vehicle's gear shifting process. In the Honda Pilot, the Transmission Control Module, TCM, monitors these components, and if it detects a malfunction in the Shift Solenoid Valve C, it will prevent the transmission from shifting to second or fifth gear via a fail-safe function. This DTC indicates an electrical problem rather than a mechanical issue, which should steer your initial diagnostics toward the vehicle's electrical circuits. Understanding this error is vital for the correct diagnosis and repair, ensuring efficient vehicle performance without jeopardizing safety. DTC P0979 specifically identifies a short in the electrical circuit connected to Shift Solenoid Valve C. The shift solenoid valves are located within the automatic transmission of the Honda Pilot and are responsible for engaging and disengaging gears based on the driver's input and vehicle speed. The short circuit can prevent the solenoid from receiving the proper signals from the Powertrain Control Module, PCM, leading to a failure in shifting the transmission into second or fifth gear. The shift solenoid itself is typically found in the valve body of the transmission. Electrical issues can arise from poor wiring, insulation failures, or damaged connectors, making it imperative to check these components thoroughly when diagnosing this code. The primary cause of DTC P0979 is an electrical circuit problem, which could stem from various sources. One common issue is a short to ground, where the wiring becomes compromised and creates a direct electrical path to the vehicle chassis, potentially leading to malfunctions in the circuit connected to Shift Solenoid Valve C. The failure may also originate from the shift solenoid valve itself. If it is internally damaged, it will not function correctly. Additionally, issues in the Powertrain Control Module, PCM, could contribute to this code being triggered, although it's less common. Furthermore, bad or loose electrical connections can exacerbate the problem, making it crucial to systematically check the entire circuit for faults. When DTC P0979 is set, the most prominent symptom is the inability of the transmission to shift into second or fifth gear, which can hinder driving performance. Often, you may notice that the transmission remains stuck in a particular gear, preventing smooth acceleration or deceleration. This situation can significantly affect the driving experience, leading to poor fuel efficiency and potential engine strain. Moreover, drivers may observe warning lights illuminated on the dashboard, indicating a transmission issue. These symptoms can vary in severity, but they all point towards the necessity for an immediate diagnostic evaluation, ensuring the safety and reliability of the vehicle. The first step in troubleshooting DTC P0979 involves problem verification using the Honda Diagnostic System, HDS. Start by turning the vehicle to the on mode, allowing the electronics to engage. Next, clear the existing DTCs using the HDS to reset the system. Once cleared, start the engine while the vehicle is in park, P, and wait for at least 1 second before checking for any pending or confirmed DTCs with the HDS again. If DTC P0979 reappears, it confirms a persistent issue requiring further inspection. If not, it could indicate an intermittent failure. In that case, inspect for poor connections and loose terminals between Shift Solenoid Valve C and the PCM, as these could lead to electrical disturbances. The second step involves checking fuse number C31, a 7.5 amp fuse located in the underdash fuse/relay box. Turn the vehicle to the off lock mode before inspecting the fuse. Examine fuse number C31 closely to determine whether it is intact. If the fuse is operational, proceed to the next troubleshooting step. However, if it is blown, replacement is necessary, after which the system should be tested again. If the new fuse blows immediately, it signals a short to ground issue in the circuit, necessitating further inspection of the wiring to identify and rectify the fault. The third troubleshooting step is to check for an open wire condition in the IG1 VB Sol line, which connects the shift solenoid to the PCM. Begin by jumping the SCS, System Check Switch line, using the HDS, and leave it for more than 1 minute. Then, disconnect the PCM connector A, which has 51 pins. With the connector removed, turn the vehicle to the on mode and measure the voltage between test points 1 and 2 as specified. Test point 1 refers to PCM connector A at pin number 1, while test point 2 is connected to body ground. Determine if there is battery voltage present at this point. If so, the wiring to the solenoid is intact. If no voltage is present, further investigation is necessary to repair any open circuits in the wire connecting the PCM and the fuse. In the fourth troubleshooting step, begin by reconnecting PCM connector A and then disconnecting the Shift Solenoid Valve C connector. After doing so, turn the vehicle to the on mode. Again, clear the DTC using the HDS to reset the codes. Once the DTCs are clear, start the engine in park, P, and wait for at least 1 second before running another diagnostic scan using the HDS. Check if DTC P0979 appears again. If it does not, the Shift Solenoid Valve C is functioning correctly. If DTC P0979 returns, then a failure in the solenoid valve is indicated, which requires replacement to resolve the issue. The final troubleshooting step focuses on inspecting the SHC Shift Solenoid control line for possible shorts. Start by setting the vehicle to off lock mode, and then jumping the SCS line via the HDS as previously done. Disconnect PCM connector B, originally with 51 pins, and perform a continuity test between test points 1 and 2, while ensuring both the Shift Solenoid Valve C connector and PCM connector B remain disconnected. Test point 1 relates to PCM connector B at pin number 3, while test point 2 again corresponds to body ground. If continuity is present, this indicates a short to ground within the SHC wire, which must be repaired. If the continuity test fails, the wiring is likely fine, suggesting a faulty PCM that may need to be replaced to resolve the DTC P0979. After completing the necessary repairs for DTC P0979, it's crucial to conduct a final verification to ensure all issues have been resolved. Start by using the HDS to recheck for any remaining DTCs, as this will confirm whether the previous faults have been adequately addressed. Next, take the vehicle for a test drive under various conditions, paying attention to whether the transmission shifts smoothly through all gears without any warning lights activating. During this drive, monitor the performance of the transmission closely. Successful repair should result in the transmission engaging normally into second and fifth gears as designed, ensuring overall functionality and safety of the vehicle. To prevent the recurrence of issues associated with DTC P0979, regular preventive maintenance is advisable. Begin by regularly inspecting the wiring harness related to the shift solenoid for signs of wear, damage, or corrosion that could lead to shorts or other electrical failures. Performing software updates to the powertrain control module, PCM, can also be beneficial, as updates may introduce fixes for bugs or performance enhancements. Additionally, monitoring the integrity of the fuses, particularly those related to the transmission system, is crucial for early detection of any future electrical issues. By adhering to a routine maintenance plan, you can enhance the reliability and longevity of the Honda Pilot's transmission system. In conclusion, diagnosing DTC P0979 reveals that the issue is primarily electrical rather than mechanical, requiring a systematic approach to troubleshooting. Key components to inspect include the wiring, the Shift Solenoid Valve C, and the connections to the powertrain control module. By following the outlined troubleshooting steps, potential causes of the DTC can be effectively identified and resolved. Ensuring the integrity of the fuse and related circuits further enhances transmission performance. Finally, implementing preventive maintenance practices will help in minimizing future occurrences, thus sustaining the overall performance of the Honda Pilot. Please like and subscribe to the channel. See you next time.